So this is for assignment number 16. Today is the 27th. And I can go over any that you'd like. I don't intend to take up your time. So, but anyways, this will be a good jump start for you. So let's get to it. This will be, I would say problem number 1, but it's actually going to be problem letter D, because that's like the first one. So step 1, still as always, is to define our variable. The difference this time is that there aren't multiple numbers. And so when we define our variable, we're just going to say like, let X equal the number. That's really all there is to it in this case, because there's not like a smaller and a larger. So in a problem like this, what you're going to see now is rather than defining 2 different things, we're going to define one and then write an equation just based off of that one. And this actually, I think, going to be simpler than maybe we think. So let's get to it. So it says 7 times the number is. When you see the word is, that has to make you think equal sign. So we're going to write an equation that states that 7 times our number is the same as, so that's like equals 12 more than 3 times the number. So what will we put on the left side of the equal sign? No, here's an equal sign. And it's, again, 7 times a number is the same as 12 more than 3 times the number. And I know that's not what the equation is going to look like, but you get the idea, right? It's literally just popping right off the page. 7 times the number is the same as 12 more than 3 times. So what am I going to replace my weird pound signs with? X. So the equation's actually going to say 7x, that's 7 times a number, is the same as 12 more than 3 times the number. Neat, huh? And simple, I hope you agree. You don't need like multiple considerations of who's the larger and who's the smaller. It's just one number, and we get in there and write an equation about the guy. And then, of course, solving this, you're like, that's easy. Who should we move? Totally the 3x. And remember that we subtract him. Don't dare put 10x. We subtract 3x, giving us 4x equals 12. X equals 3. The problem said, find the number. I would say, we could say the number is 3, put a box around that, and that is that. All right. Any others on there from looking at them that you want to go over, or do you want to just ask as you go? And every time someone asks a question, I'll just keep a recording going and I'll pause it. And then if you guys have a question, I'll remind me to unpause it again for the guys that aren't here, the guys and gals. Then I can unpause and they can not have to wait while we all work. Okay. Sound good? All right. Anyone's interested, we're going to go over problem Y, which is the 5th one down. So we're going to start by just setting our number, because there is only mention of the one number in this case. So this will be another one where we just say, just let X equal like the number, right? So just so we're clear on that. So it says 12 less than a number. How are you going to write 12 less than a number? Good job. Yeah, so 12 less than our number is the same as 6 decreased by. With decreased by, we don't do it backwards. It's like just literally in order. So 6 decreased by means 6 minus, and then 8 times the number would look like this. Does that make sense? And then from here, I wouldn't hesitate, like the steps that I personally do, I would add the 8x across to the left. And since I already have 1x, when I add my 8x across, I would now have 9x's. And then by default, I would have to add the 12 back across to the east, giving me 6 plus 12.
Oh, I don't think I did it like this. I think I added wrong. I added that wrong.
Did you get like -6? Yeah, see, and the problem with that goes just fundamentally back to about a month ago when I told you guys you didn't have to show work. And you just have to remember that you're not adding -12 and 6. You are literally adding 12 to both sides of the equation. So the -12 no longer exists. We kill it off, right? That's important. So you good to go from there?
Yeah.
You're welcome. We are going to go over question T. So this is letter T. It's the second one down in the right-hand column. So I would think that, I wonder if we can, let me make sure I can do this. Okay, so doing question T assumes that you've done question K. Did you do question K? You guys might want to watch this. This is a difficult question. There's a trick to it. Like you really should stop what you're doing and watch this, because there's going to be this idea that's going to pop up now periodically, and I don't think that it's easy to figure out. So in question K, right before this, they give you a hint, and if I lose you in the next minute, just tell me and I'll try again. So if I have two numbers, I'm going to call them like X and Y. I wouldn't write this down if I were you. And I told you that they added together to make like 50. This isn't the problem. I'm just making this up. Don't panic yet, right? This is just me saying I've got two numbers and they add together to make 50. Or, I mean, I could even change it. And instead of using two variables, I could say that I have a larger number and a smaller number, just so it'll maybe fit better with your problem. And I'll even do you one better. I'll go with your problem, because do you agree in problem 2 that it says that the numbers add to make 24? Yeah. See that, right? Okay. So can we agree that if I were to figure out what the larger number is, that I would have to move the smaller number to the other side? Just look at the board and think about the basic algebra. Like you've done this, I can say now literally 1,000 times. You've gotten something by itself. So if I wanted to know what the larger number is, do you agree that it has to be 24 minus the smaller number? And that's just me going like this. I'm just subtracting the smaller number from both sides, right? So don't panic. I'm just moving it to the other side. Do you understand? Okay. So we can safely say now that the larger number is 24 minus the smaller. Or if I had done this a different way, let's say that instead of solving for the larger number, I had said, what's the smaller number? Well, what would the smaller number equal? I mean, you really should only be looking at the TV right now, because there's nothing on your paper that's going to help you at this point. I'm just trying to make a very huge point here. Of course, if I want to know what the smaller number is, then I have to take the larger over to the other side and say, well, then the smaller, you must be 24 minus the larger. Okay, that's the hint that's given to you. If you did problem K, that's the hint that they're giving you in that problem. So what we're going to do is we're going to follow that same mold, and we're going to head into problem letter T, and we're going to define like they did. We're going to do let X equal the larger number. So I'm going to put blank here. I'm going to put let blank equal the smaller number. So if you're someone who gets nervous by math, you're not going to be able to answer this. But if you're someone who just absorbs, you already know how easy this is. What's the smaller number? You already know this because I just did it on the board. It's got to be 24 minus the larger one, right? And actually, I mean, yeah, I mean, I almost wonder if I'm okay with this just because I feel like I wonder if we have them backwards, but I think we're going to be okay. Let's try this and see how it feels as we work through the problem. But listen, what I'm trying to get at here in my long-winded way is if all someone tells you is that two numbers add together to make a number like 24, then one of them is 24 minus the other, and the other is 24 minus the one, right? Like Tegan and I, our ages add together to make, I bet like 63. I bet if you were to add our ages together, you'd get 63. I'm guessing you're 14, 13. So we add together to make 62. So I could say that Tegan's age is 62 minus 49. That's mine. Or my age is 62 minus 13, 49. It still works. Okay. So this is how you're going to define variables in these sorts of problems. And they're harder than they look until you get started. And now it's going to be easy because we're going to follow the problem now. And it says, okay, 7 times the smaller number. So let's see how this looks. 7 times the smaller number. What's the smaller number? 24 minus x is the same as, so I know what to put for that. Got a sign for that in math. It's called an equal sign. Is the same as 5 times the larger number. And what's the larger number? Good. That entire 5 minutes of yours that I just ate up and talked to you was to make this point and this point alone. In a problem where they just tell you what two numbers add up to make, this is how the relationship gets set up. Had they added up to make 85, then my larger number would be x and my smaller number would be 85 minus x. That's just how relationships with numbers have to work. As always, you know this by now, once steps 1 and 2 are done, we shouldn't be struggling with step 3. We've solved so many equations that we just don't struggle. We know to distribute. We know how to move x's around. What's 7 times 24? 168. And then we distribute the 7 to the x and get what? Minus 7x equals 5x. And then what? Yeah, you just don't have a choice. You've done enough of these to know if you move the 168, that's stupid. You just got no one to go with. And if you move the 5x, that's stupid because then there's nothing left. There's always only one choice with equations that look like this. If I add the 7x across, I get 12x's is equal to 168. And then when I divide by 12, I get x equals 14. So the question now is, and this is where the multiple variable declarations is the key. Who did I just find? And the problem says find the smaller number. So I don't want to put a box around this or anything. I want to make sure that I answered the question. The question was, what is the smaller number? And that means I'm going to take 14, follow the yellow arrow, and I'm going to put it right there. Right at the end of that arrow is where he goes. What is 24 minus 14? 10. So I can say that the smaller number is 10. And that is what I would present as an answer. Does that make sense? I'm glad you asked about that because K and T are both, on K, they did the variable declaration for you, but then on T, they kind of say, okay, you're off, go fly, you young birdie, you know, like you're on your own. So, all right, I'm repausing. If you have more questions, just keep asking, okay? We are going over problem L, if anybody's interested. L. That's the Beth and Keith and Hank problem. I'm going to call Henry Hank for the duration of this problem. Is that okay? Can I do that? You know, the great baseball legend Hank Aaron was actually Henry Aaron. Did you know that? Okay, that was a tidbit for you. As always, when we read a problem like this, we have to read it and decide who's never discussed. You've heard this theme before. So when we talk about Keith, Beth, and Hank, who never gets specifically defined? Yeah, they tell us about Keith and blah, blah, blah. Keith does this and this. And they tell us blah, blah, blah. Henry does this and this. So we want to let X equal Beth's weight. Remember, you don't want to do a ghetto variable declaration and say let X equal Beth. That's lame, right? That could mean a million different things. So after that, we're going to define Keith because Keith is defined based off of Beth. And what is Keith?
Keith is
20 more than Beth. And so we're going to let Beth plus 20 equal Keith's weight. Does that make sense so far? Okay. And now we have to define, I guess we're down to Henry, Hank, and Hank is 30 less than twice as much as Beth. So we're going to let something equal Henry's weight. Right. He is quite literally 30 less than. I always write that first in hopes that when young people watch me write that, that just gets stuck in everyone's head. You should always write your less thans and more thans first, but at the end. And then he's 30 less than twice Beth, and twice Beth is a 2x. So it says that Keith and Henry weigh the same. So that means that I'm going to take this big, powerful symbol in math. We know this guy as an equal sign. And if I ever want some two things to be the same, the fun thing about algebra is I can just make it happen. That's what algebra is really for, is that creation of a relationship and saying, if you want this to be true, I'll write it to be true. And if you tell me that Keith weighs the same as Hank, then doesn't that just have to be true? And the question might be, someone might say, what about X? And that's just, I hate that question because it's like, listen, we needed to define Beth because it's upon her foundation that we build all the others, right? So we had to declare Beth to be X. Great. But we're not mentioning Beth in this equation. These things that we have were created by Beth. Keith's weight and Henry's weight are based off of Beth, but she just doesn't come up in the equation, right? So when we solve this, what's our best course of action? Yeah, and then let's also, while we're here, add the 30 to each side. And we just figured out something very quickly that I think we want to know. What's the question say? So we can now say, well, Beth is X, isn't she? So I think we can just write a quick little sentence and say Beth weighs 50 kilograms. You know, had they asked us for Henry's weight or Keith's weight, we could have just plugged them back into our awesome little red variable declarations. Got that there, Dice? Nice. You don't, because we used Beth to define the Keith weight and we used Beth to define the Henry weight, but she never comes up in the equation, so we just leave her out. But I like, ironically, we leave her out. I'm putting air quotes there. We leave her out, but the reality is that when we solve for X, then we're really actually going back and finding her anyways. So yeah. Say again. Ah, yes. Reading. Pausing again, so let me know if you have more. N. Last problem on the first page, the one about the bikes. Do you know what the N on the Nebraska Cornhuskers football helmet stands for? No, knowledge. I know, that's the joke, is that they don't know how to spell in Nebraska. Do you get it? Ah, WYO. Yeah, that's right.
I'm like, I'm on the border. You can hear, and, yeah, there was a lot of, and we were underneath the living room and from both spring and Nebraska.
So I should assume she was rooting for Nebraska
Yeah.
while the others were rooting
Oh my
for
God.
Wyoming. Good. That's healthy. Those are the best games to watch when you have multiple people in the same room who still love each other, but are rooting for very different reasons. You know what I mean? All the smack talking. Um, so we have to think about when we define in the second sentence, this is again problem N. We're talking about we read that second sentence. Honestly, the first sentence is useless. I hope you understand that's just useless dribble. I don't care what the company's name is, and I would have figured out what they manufacture anyways. So, I mean, okay, let's go ahead and skip that. The second sentence says that they made 88 more bicycles than unicycles. So understand that that is a description of bicycles. That is not a direct addressing of unicycles. That is bicycles. So we don't want X to be the number of bicycles, right? And then in the second half of the sentence, it says they made blah 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 tricycles as units. So it's definitely unicycles is going to be our X. Do we agree? Okay, so we're going to let X equal the number of unicycles. So remember, don't put let X equal unicycles. Make sure you're specific and say number of unicycles. I feel satisfied that you've gotten the point about who to pick for your X. I'm pretty happy and proud about that seems to be what we're good at. And that's really huge. So now that we understand who our base is, X is unicycles made. From the first half of the second sentence, how could we define the number of bicycles? Yes, so I'm going to let X plus 88, because that's 88 more than equal the number of bicycles. And then finally, I need to define the number of tricycles as something, and it's based off of unicycles. So what is it? Yes, this is not one of those fancy ones because they're not, the tricycle number is not being based off of the fancy bicycles. The tricycle number is just 5 times the OG, the X. So 5X is the number of tricycles. Don't you like the what are those called? Prefix? That's a prefix, right? Look at the prefixes. Uni, bi, and tri. Neat, huh? They're all cycles with different numbers of wheels. So now it's time to write an equation. So if they made 40 more bicycles than tricycles, so you have to, well, you don't have to. You don't have to do anything. I hope you agree with what I'm about to write. If I take, so they made 40 more bicycles than tricycles. So the way I interpret that is if I take the number of tricycles and I add 40 to that, then I should get the number of bicycles. My teachers used to make me do this. This, by the way, is something called, ready for this? Verbal modeling. And I used to hate it as a kid. It's like, yeah, this is lame, stupid. And as I get older, I just say, man, putting things in words, huge. Because that's a sentence that you need to look at and read until you agree. That the way that's phrased is, first off, who they make more of, bicycles or tricycles? Definitely the phrasing of that is they made more bicycles because they're saying they made 40 more bikes than trikes. So that's why I have to take the number of trikes and add 40 to get the number of bikes. Yeah, so that's going to be, yes, that's going to be now, if you understand that, that sentence is my sales pitch. If you can get that, my job is done. That white sentence is everything. If that makes sense, then yes. Ms. Orozco, yes, yes, yes. We're going to just plug some stuff in here. So where it says number of tricycles, I'm like, oh, I'll just put 5x, and then 40 more than that is the same as the number of bikes. And how many bikes were made? X plus 88. You really start to see in a problem like this where the variable declaration is just the king. Without what we have written in red up here on the board, this problem is almost impossible. But with that, it's just like a little platter where we can pick what we need when we go to make our equation. Just pick it easy. And then as always, here comes step 3, which ought to be super light work by October 26th or 27th. So subtracting x gives us 4x. Subtracting 40 gives us 48. Y tienes que dividir los dos lados por 4. X, ¿cuáles? 12. Perfecto. What did we just find? Yes, and our variable declaration tells us so. You know, I would be ashamed if you were to get X and go, what does that mean? That's hurtful. The whole reason we define variables is so that we have them when we need them. And I look up here and say X was the number of unicycles. Okay, cool. So now I'm going to read the question and start figuring out. Let's see, blah, 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 blah. How many unicycles did they make? 12.
Oh.
Because it's literally what we're looking for is our base variable up here at the top. Our base variable is the number of unicycles. So what I hear is, well, heck, if I find out what X is, I'm done. So they made 12 unicycles. Make sense? Whose question was that? Was that you?
Yeah.
Then are you okay with it?
Yeah.
Tricky, but doable. Repausing. I don't know that I'll have time for any more, but if you have any quickies, I can